Today we are covering lesson 4.2, which is the unit circle. If you are new to the unit circle, this exercise I'm going to show you right here is what you need to practice. Probably as much as 3 to 4 times a day until you can get it down. You need to be able to fill in this grid that's going to talk about the x and y values of 0 degrees, 30 degrees, which is also pi 6, 45 degrees, which is pi 4, 60 degrees, which is pi thirds, and 90 degrees, which is pi half. Okay, and the values are 1 or 3 over 2, or 2 over 2, 1 half, 0 for my x values. For my y values, the exact opposite. We're basically going this way on the graph. And they also come from that 413 lesson video on the right triangles. The reason is, what will happen is we'll learn some relationships with x and y, and that cosine kind of aligns with the x value, sine is the y, tangent is going to be y over x. That from this chart, I can give you all these values. However, I can also do them for any of the 4 quadrants. Currently, everything is positive here, so it's quadrant 1. But we can do them for quadrant 2. X is negative, y is positive. Quadrant 3, everything's negative, except for tangent. And quadrant 4, cosine's positive, sine's negative. Again, that's something you should practice filling out like a flashcard. So moving on, for those who weren't sure, what do you mean unit circle? At this point, you should have your blank unit circle, pause the video, and fill in the chart. If you haven't paused yet and you haven't filled in, great. But if you've paused, hopefully you've got it all filled in, and we're going to move on. But these are the points that I had in that table I just showed you. But if we go back, my first point was 1, 0. Right? X value 1, y value 0. My second one, square root of 3, 1 half. Square root of 3, 1 half. And so, again, those come from these right triangles I can draw here, right? The only goofy ones are 0 has an x value of 1 because our unit circle starts here and rotates counterclockwise 4 degrees. So if I went for 150 degrees, it'd be over here. Okay? It does help to memorize it in radians specifically, so I'm talking about pi angles. If you need to convert, it's pretty easy to convert, right? Times 180 over pi, and you can kind of figure out your name. So definition of trig functions. Some people might think, we did this the other day, why do we need to write this again? This is more specific to sine of t is the y value in the unit circle, right? So again, in unit circle. Because we will also do this one more time, not in unit circle. Cosine is the x value, and tangent is sine over cosine, hence y over x. Cosecant is 1 over y, right? They're reciprocals. These two are reciprocals. Secant, 1 over x. Same thing, these are reciprocals. And cotangent, again, if you flip, right, if you write it like this, you can solve and just get it nice and neat to be y over x. Okay. Now we will use those values for the rest of this lesson. So next, something we did similar to yesterday, determine all 6 trig functions from the angle t is 5 pi 6. Now, again, as a seasoned veteran of the unit circle from years of practice, I know 5 pi 6 is over here. Early on, you may need to go back to your chart to write in what is that point. Right? Because what we're going to do is we're going to have a point here, which is going to be negative 3 over 2, 1 half. Right? And what I want you to start thinking is, how is that related to the chart here? Right? We had 5 pi 6. It's the same values, but this one's negative, right? Because we're in quadrant 2. So, how did I know? Pi 6. This one's also pi 6. We'll get to a lesson on reference angles, and that is why I'm using pi 6 to find it. So I've got my value. This is x and y. I just need to plug it in. Sine is y, so this one's 1/2. Cosine is x, so my answer is negative root 3 over 2. Tangent's y over x, so 1/2 over negative root 3 over 2. The 2's cancel. This is negative 1 over root 3. Simplifying, we're going to get negative root 3 over 3, right? You got to do this rationalizing the denominator. So there's my tangent value. Cosecant, we're just flipping. What's 1 over 2 becomes 2 over 1. Negative square root of 3 over 2 becomes negative 2 over square root of 3, and then we got a little bit more work here. Square root of 3 top and bottom, and we get negative 2 root 3 over 3. And lastly, cotangent is, I like to go back right here. Right, negative 1 over root 3 becomes negative root 3 over 1, which is negative root 3. Or again, you can go back to here and do negative root 3 over 2 over 1/2. Right, this is why the halves cancel. We times by 2 over 2, we get negative root 3 over 1, which is just negative root 3. The more you practice being able to write that chart down that I wrote on the very first slide, the better this will be for you. Okay. Find the point on the unit circle that corresponds to the real number p. So if the angle is 5 pi third, what is my xy value? Okay, right, 5 pi third is going to be in this quadrant down here, probably about there. Right, this is the one that has a negative y value, positive x value. So that is my point, 1/2 negative root 3 over 2. Some people were a little more successful in trying to remember what's the triangle that has a pi third name, right? That is 30, 60, 90, but that's a 60-degree angle where we have root 3x, x, 2x, but the difference is this is 1. So we have to divide everything by 2, and that's where we get negative root 3 over 2 because we went down for the y value, positive half of the x. What about 11 pi 6? Very similar, or even further, there's 30 degrees left. So this is like looking at the triangle from the 30-degree level, right? This one's going to be negative half. This is root 3 over 2. Again, assuming we're at 1. So again, root 3 over 2, negative half. And again, if you have to keep going back and referencing that unit circle individual sheet that you filled out from slide 2, that's fine. This is the first time. But as you get going through the lessons, you will want to practice and become comfortable with that to where you kind of have an idea without having to look at your unit circle. And 2 pi is the 0.10, right? That's a 360-degree circle. We're back here, which is radius 1, x is 1, y is 0. Definition of a periodic function is a function that has a period. How's that helpful? But what does a period mean, right? A period means, in this, is that the function is going to repeat after a certain amount of time. Now, the reason this is important is because sine and cosine are periodic functions. So is tangent, right? Sine's repeat is every 360 degrees. Well, we don't really use degree anymore, so the period is 2 pi. Oops. So sine period is 2 pi, so it's cosine. Well, domain, what values can we plug in? Any, right? Negative infinity to positive infinity. Same with cosine. Any numbers work, no issues. What's the lowest value we'll get out? Negative 1. What's the highest value? 1. Same thing with cosine. And there's that chart, right? Evaluate the trig function using a period as a name. So what it wants us to do is to get this angle here so that it's between 0 and 2 pi, right? And then we can figure out the value once we have it there, right? I do not have this on my chart, but I'm asking myself, is it too high or is it too low, right? 15 over 4 is almost 4, right? This is 3 3/4. So it's too high. So I need to subtract 2 pi for my angle. And why 2 pi? Because that's 1 period, right? If I'm subtracting 1 period from my angle, I'm going to get the exact same result, right? And when we finish, we can plug it into our calculator and double check. I'm very sure it's going to work. Yeah. So 15/4 minus 2 pi, which is 4/4. So 15 minus 8 is 7 pi/4. And now that point, right, is root 2 over 2, negative root 2 over 2. And what's it asking for? It's asking for the x value. So my answer is root 2 over 2. Next one, what if it's too low? This one's negative 8/3, which again, if I kind of change it into this form, it's too low. I need to add 2 pi, and I might need to do it more than once. So negative 8/3 plus 2 pi, which in third pieces, that's why I'm multiplying by 3, I get 6. So negative 8 plus 6 is negative 2/3. I still need 6 more. I got another 2 pi. So adding 6 more thirds, I've got 4/3. So I've got the point. Now I need the y value, right? The sign is y. So what's the y value at 4 pi thirds, right? It's going to match the y value at pi thirds, but it's going to be negative. Okay, so at pi thirds, we're root 3 over 2. So my answer is negative root 3 over 2. Next one, 11 pi is way above 0 pi. So I just need to keep subtracting 2 pi until we get there. 11 minus 2, we're at 9. 9 minus 2, 7. Minus 2, 5. Minus 2, 3. Minus 2, 1. So sine of pi is the same as sine of 11 pi. Well, what's pi? Right, it's like a 180-degree angle where my point is negative 1, 0. So what's the y value? The pi value is 0. All that work for nothing. Next one, cosine of negative 3 pi 4. Go ahead, try this one on your own. You pause the video and then see if you get it right. So how'd you do? Okay. Negative 3 pi 4 is too low. I need 0 to 2 pi, so I had to add to get to that point. Adding 2 pi in terms of 4/4, which is 8/4. 8 minus 3 is 5/4. And 5/4, again, is way down here in quadrant 3. Everything's negative down there. And pi/4 is always the root 2 over 2. So negative square root of 2 over 2 is cosine of negative 3 pi 4. Next, even and odd functions. So just a little reminder, even functions are spot functions that can eat the negative sign. Odd functions are ones that throw the negative sign in front. Okay, so what does that mean, right? Remember, x squared was an even function, right? Because if I had negative 3 squared, that was the same as 3 squared, right? The negative sign didn't matter. Now with cosine, right, cosine of negative t, I can switch it to being cosine of t, right? The negative sign disappears because cosine of negative t equals cosine of t. Now these are reciprocals, so I don't need to memorize a bunch. I just need to memorize this is the only one that's even. The rest of them, the odd, will have the ability to take the negative side and put it out front so that it's minus sine of t. So I'm going to say like, okay, so what's the big deal about this? Well, I can give you, sine of t equals what? Some number, and you can tell me what cosine of negative t is just by being able to kind of draw a triangle, figure out what adjacent is, and then, right, realize that the negative is going to be eaten and give me cosine of t, right? So let's see what else. And then, of course, tangent, because it's made up of one of each. Cosine is going to eat the negative, sine won't, so it ends up being odd. That it's going to kick the negative sign outside, right? It moves the negative sign outside. What do you know? It starts with O, where it's even. I use the word eat it not to be silly, but it starts with E. Even eats the sign. Use the value sine of t equals 2/3 to evaluate sine of negative 2t. So what I'm going to do first is remember that the negative sign moves to the front, And now I can plug in 2/3. So sine of t is 2/3. Negative sine of t is negative 2/3. That's it. Okay, you just have to move the t out of there, then we can substitute. Next, what about cosecant of t? Reminder, this is 1 over sine of t. So we're basically reciprocal what we have here. So sine of t is 2/3, cosecant of t is 3/2. Right, because each one has a co. Wrapping it up, we've got a couple more. Plug them in your calculator, and the rare time where we are actually rounding to 4 decimals, we've got sine of 4.2 pi. Now, this is radians, so we need to hit mode, go back to radians. Sine of 4.2 pi. Now, some of you are doubting that 2 pi is the period, how it works. Go ahead and hit sine inverse. So sine 4.2 pi. Sine inverse is something we'll get into at the end of the chapter. Now, if you were curious about that 2 pi issue that I was talking about earlier, right? What if I subtracted 2 pi? I'll just make it do the math. And I get the same answer, right? Just showing you that that's the period. Even the calculator recommended it. So 5878 is my answer. Next, secant of 5, which I'm going to do 1 over cosine of 5 as a reminder. .5253. So go ahead, test those last two out on your own. Tangent of 3 pi half and cotangent of 2.1. And there's our answers. 13 was a domain error. You were trying to do divide by 0 kind of with doing 3 pi half. So x is, y is -1, x is 0, -1 divided by 0, undefined. And then the next one, -0.5848. That wraps up this lesson. Don't forget to practice that unit circle chart. And just one extra thing. How can you maybe think of a shortcut for the unit circle chart? This interesting shortcut I saw basically said, okay, there's 5 spots. You're going to start with 4 and count down. And now, clearly our numbers weren't as high as 4, so then what we're doing is we're going to square root over 2 each number. Now, some of them look really weird, but we're going to simplify this. What's the square root of 4? 2. 2 over 2 is 1. Square root of 3 over 2, that one's fine. Square root of 2 over 2, also fine. Square root of 1 is 1 over 2. And then 0 is a 0. So that is all my x values for the chart. Easy as counting down from 4. What about my y's? I just need to rewrite these going this direction. 0, 1/2, root 2 over 2, root 3 over 2, 1. Right? And again, we started with 0, pi 6, pi 4, pi thirds, pi half. And that is kind of a neat trick to learning how to kind of come up with a chart really quickly.